Calcium is not merely a chemical on the periodic table, and nor is it just a component of the milk that you consume to help strengthen your bones. Calcium is integral to the rhythmic contraction and relaxation of the heart, and it's this repetitive process which enables the heart to pump oxygenated blood around your body, a function which is critical for life. Now, the heart itself is made up of a jigsaw of cells, and on the slide here you can see a partial of one of these cells. Within each of these cells there is a compartment which contains calcium. You can actually visualize the release of calcium from these compartments by using calcium sensitive dyes. This is done here in the image in the small red box with an increase in fluorescence representing a release of that calcium into the cell. Calcium is released via one of the largest proteins within the human body. This is called the ryanodine receptor, and it acts like a gate. The opening and closing of this gate is regulated by a various number of other proteins, namely junctophyllin. And as you can see here in the schematic, they're closely related to form a structure known as the calcium release unit. Now, within the UK alone, there are over 500,000 people who are living with heart failure. Within the failing heart, the movement of calcium becomes very chaotic. This results in the heart becoming weaker, and therefore it can't efficiently undertake its function. My PhD is looking at why this calcium becomes chaotic. So, if I draw your attention back to the slide, looking at this heart cell, the width of the heart cell is approximately 1/5 the width of a strand of hair. The width of this structure here, the calcium release unit, on the other hand, is 1/1000th the width of a strand of hair. Within heart failure, it's believed that there's a change in the structure of this calcium release unit that's related to a change in the functional release of calcium. However, imaging techniques have so far been limited in providing the ability to actually visualize changes at this scale within the heart. And how can you possibly begin to understand something that you cannot see? Therefore, within my PhD, I'm actually using a Nobel Prize winning technology called super resolution microscopy. This imaging technique allows you to visualize fine changes in structure at an exquisite level of detail, so you can understand what structural changes may be happening in the heart and how that relates to any changes in the functional release of calcium, and relate this to the failing heart with a healthy heart, and actually begin to understand how we can restore calcium's role within heart failure.